Dirt is actually kind of like a swear word. This is the organic layer. And you can see down here, the water moved quite quickly and drains very fast. Does the soil feel very gritty? No, it doesn't. It's pretty smooth. Hi everyone, my name's Ranger M, and I work at Catfish Creek Conservation Authority. I'm the community outreach technician, and that means I do a lot of this, chatting about all things nature and conservation with kids, adults, teachers, everyone. I love to knowledge share, and that's just what I'm going to do with you. So come on, let's go learn with Ranger M. Have you ever wondered what's actually going on the forest floor? Or what you're holding when you have a fistful of dirt? Or what really is soil? Well, that's what we're going to be discussing today. We're going to really dig deep and get the dirt on soil. Now, you may already know this, but soil is a naturally occurring organic material that is mostly made up of abiotic components. And abiotic means non-living. But when soil is interacting with different ecosystems like a forest, a wetland, or a tallgrass prairie, it's interacting with a lot of biotic or living components. And that means soil is also biotic. The average depth of soil is about 1 meter. But if you compare that to the entire size of Earth, that's a small fraction. Therefore, we can consider the soil the skin of the Earth. And we know how important skin is to us. It protects all of our insides, and that's what soil is doing for the planet. Soil is made up of a lot of different things. Nutrients, minerals, gases, liquids, they all make up soil. Soil is also very porous, like a sponge. There are our solids, the mineral grains and organic matter, both living and dead, and that makes up the soil skeleton. Then there are the empty spaces, and that's between the solid particles, and that's our liquids and gases. About 50% of soil is actually air and water, while the other 50% is broken rock and decaying plants and animals. So this leads us to the word dirt and what it means in comparison to soil. Dirt is actually kind of like a swear word because it has no place here in the soil world. Dirt is what is under our fingernails or on our clothes. It has no viable nutrients, it cannot support life, and it's actually dead. Whereas soil is viable, full of nutrients, and can support life. Soil provides essential functions in almost every environment, whether it be a farm, a forest, a wetland, a tallgrass prairie, even in a city. They all perform important roles. Soil absorbs, holds, releases, alters, and purifies most water in our terrestrial ecosystems. Therefore, soil considerably helps filter our water of pollutants, sediments, and other things before it enters an aquifer. Soil provides the main media and platform for vegetative growth, including our crops that feed the world's population. More than 95% of all foods come from soil. Soil supports biodiversity. Not just vegetative, but also groundhogs, salamanders, and moles all depend on soil habitats, as well as our necessary bacteria and fungi. Soils host more than 1/4 of the world's total biodiversity. It emits and absorbs gases, having an important interaction with the atmosphere, including greenhouse gases like carbon dioxide and methane. Soil provides physical support for our trees and vegetation, as well as our infrastructure like buildings, schools, and houses. Soil also cycles nutrients, meaning it can recycle important nutrients like carbon, nitrogen, and phosphorus, allowing living things to use them over and over again. Here in southwestern Ontario, or more specifically the Carolinian Life Zone, we actually live in this area called the agricultural belt or the banana belt. And that's because we live in a more warmer and moist climate that has better soils to host a variety of different crops and has very few limitations when it comes to cultivation and crop production. When it comes to planting crop fields, there's actually a classification process. It's from class 1 that has very few limitations, all the way increasing in limitations until you get to class 7 that has no capability for arable culture or permanent pasture. This is common in Ontario in and around the Muskokas or farther north where we see more forests than we see grazing or crop fields, or more locally, actually Long Point, because it has such a unique biosphere, it can't really host crop production. Therefore, since we've affectionately been named the Banana Belt, you can guess that we have very few limitations when it comes to agriculture. We have pretty level grounds, they're deep, they're well drained, and we have a good ability to hold nutrients and water. Using the wrong type of soil or unhealthy soil can really impede the growth and survival of vegetation because the roots can't access needed nutrients and water. Therefore, this information is so vital to farmers, environmental planners, and engineers who depend on soil. Therefore, sometimes it's really important to test and identify our soils. So let's go try and do that. Did you know soils act as a carbon sink? How much of the world's carbon dioxide emissions are stored in soil? How much of the world's carbon dioxide emissions are stored in soil? Approximately 10% of the world's carbon dioxide emissions are stored in soils across the world. A very important thing to know before we get into testing and identifying our soils is to know about permeability and porosity. And that'll actually help us understand and identify our soils even better. Porosity and permeability are actually directly linked to the pore space between each particle in the soil. So permeability is the ability of water or another liquid to move through the soil. And porosity is the substance's ability to hold a liquid. Therefore, a permeable substance is not very porous, and a porous substance is not very permeable. So here I have 4 different examples to show you the difference between porous and permeability. So I have gravel, sand, silty soil, and then also clay. And we're going to see the difference of water moving through these substances. We're going to start with our gravel, and you can see down here the water moved quite quickly and drains very fast, meaning it's very permeable and it doesn't hold water well at all. Which is why we find gravel along waterways. They put them along ponds if they are in your parks or cities or green spaces, as they let the water dribble through into the pond or creek, or also recharge our groundwater. Next, we're going to move to sand. Just put a little water in there. And you can see it's moved pretty quickly through the gravelly sand as well, relatively finding those spaces between the particles to go through. And now we're going to move to our silty, loamy soil. And you can see it go beside the water bottle and also make its way through and finding those pores. So the soil particles in this one are absorbing more water before it goes directly through, so therefore porosity-wise it is holding water better. And actually you can feel a dramatic weight difference when water went into it and from what it was. Now we'll move on to our final one, which is clay. If you've ever played with clay, you know it's a pretty dense material, so we can probably predict what it will do, but here we go. So it's draining through, it's finding the cracks between the clay, but you can see the water on top of the clay. It is holding it a lot more than it did with our other ones. So that's because clay is very porous. It holds water on top of it and in its pores dramatically more than, let's say, our gravel. So as I said, permeability and porosity helps us identify and understand soils. Another way is by seeing how soils are formed. Soils are formed in layers, which are known as different soil horizons. These soil horizons are differentiated between different chemical, physical, and biological components found in the soils. Horizons are actually incredibly easy to see because they have different colors and physical structures. And one of the easiest ones to tell is the first layer, which is known as the O layer, or the organic layer. So let's go check it out in Springwater Forest. This is the organic layer, a very recognizable layer that we find commonly when we walk through a forest. So it's all of this, it's the undecomposed leaves and plant residue, also combined with the decomposing leaves and plant residue. This is all the organic layer, and it really helps provide nutrients for the soil farther down. You may not find organic layers in all ecosystems, like our front lawn. We don't have an organic layer between our grass and the soil underneath the grass. But in a forest like Springwater, it is very common to have this organic layer. And actually, hundreds of years ago, this organic layer would be much deeper And because of the introduction of the earthworm, it has dramatically decreased over the years. The next layer after the organic layer is the layer A, and that is your surface soil layer. This is a layer of mineral soil with most of the organic matter accumulated and our soil life. This is where plants uptake most of their nutrients from. The next layer is layer B, and that is our subsoil layer. This is the horizon, normally less organic matter, but its color is mainly derived from iron oxides weathering away in the soil. So it gives it a reddish-brown color. Our next layer is layer C, which is the substratum layer. This is a very rocky layer with very poor nutrient levels. It also is where our more soluble compounds like calcium carbonate have accumulated. And our roots actually don't reach this layer as they stop in the B horizon. Another reason why there's poor nutrient levels. There's less organic material accumulating here. Our final layer is the R layer, and that's the bedrock layer. This is referred to as the parent material. The makeup of this material determines the makeup of the upper materials. So in and around the Great Canadian Shield, that is more of a granite bedrock parent material compared to the St. Lawrence lowlands, which is limestone bedrock. These parent materials were actually impacted and influenced by the last glacial movements. So these big glaciers were carving through the ground, changing the topography, and changing the chemical and physical components of our soils and that parent material. Those parent material, along with topography, climate, and weathering processes, those all influence our soils and change the soil horizons. And soil horizons, knowing and identifying them is really important for environmental scientists and other careers like forensic scientists, because knowing and understanding those changes can tell you a lot about what's happened in recent past or even a little bit farther, like hundreds of years ago. Did you know one handful of soil contains more life than there are people on Earth? Did you know one handful of soil contains more life than there are people on Earth? Soil is at the bottom of the food chain, yet it is the cornerstone of life on Earth. Actually, if you live in a very moist climate, you only need a tablespoon of soil to have more life than people on Earth. So now that we have a basis of how to understand and identify soils, we're going to go through a couple examples of identifying soils. Now, one of the easiest ways to ID something is based on what we see. And with soils, that's color. Now, using colors like brown, red, and silver or gray is descriptive, but it's not very accurate. It's like me telling you about this soil and how it's brown and there's a little bit of red and gray, which is cool because you can see the different layers and everything, but it's not very accurate. It doesn't tell you what type of soil it is or anything. So we actually can use this Munsell color notation system, and that actually is a book full of different soils you can find all over the world, and anyone can use it by just looking up their soil or comparing it by color to this book, and it'll tell you where you can find that soil all over the world and what it is. And it's similar to paint chips that you go to the store to paint your kitchen. You get these little chips to test the color or whatever, and it's kind of like that. It's a book full of these chips where you can directly compare the color to the soil you're trying to sample. Now today we're mostly going to go on texture, and texture is really important because it shows us different physical and also sometimes chemical and biological components of the soil. So we're going to use an example. I have my first one. I just want a little piece, it's fine. I also want to add some water. We are following this chart. It's known as a soil ID chart, and it shows us how we will directly follow along and get to our answer of what type of soil it is. So for this one, I have my soil, I've added some water, and I'm going to roll it into a semi-ball. So when squeezed, does the soil remain in a ball? Yes, it does. Place the ball of soil between thumb and forefinger, gently pushing the soil. And then I want to squeeze it into a ribbon, like that, so it forms a ribbon. Does the soil make a weak ribbon, a medium ribbon, or a strong ribbon before it breaks? medium strong ribbon, but I'm gonna go with medium. I'm gonna excessively wet a small pinch of the soil in palm and rub with forefinger. Does the soil feel very gritty? No, it doesn't. It's pretty smooth, and therefore I get to silty clay loam. So it is majority clay, but there is some soil. It's not completely clay. So therefore that probably would mean it has larger permeability than it does porosity. So if it was really thick clay, it would be more porous than it was permeable. So this one's a bit more permeable than what we can get with our full out clays. As a reminder, permeable means the ability for water or another liquid to move through the soil, and then porous is the ability for the substance to hold a water or a liquid. Moving to our next example. So I have my ball of dirt. I'm going to start with my squeeze. Stays relatively in a ball, and then I'm going to start my ribbon. All right, doesn't really make that much of a ribbon. Therefore, it is loamy sand. So that's not really surprising in this area. We do have some pretty light sandy soils. It is linked to our agricultural ability. So we do have a lot of tobacco fields, and that's because they prefer those sandy light soils. Do you know which invasive species has dramatically altered the state of our forest soils? Do you know which invasive species has dramatically altered the state of our forest soils? The earthworm is an invasive species to Ontario and North America, but they're also known as ecosystem engineers, just like the beaver. They have the ability to change the basic processes and structures of an entire ecosystem. Soil is one of the most critical resources we have on Earth. Unfortunately, soil and its functions are commonly overlooked. However, without soil, we would have no life on Earth, and we need to recognize and push forward the importance of soil and how we can protect it. Now, even though we know soil is a renewable resource, it takes thousands and thousands of years for fertile soil to develop. Therefore, in human years, we should see it as a non-renewable resource, therefore proving it's even more important to conserve soil. Our scientists are telling us that soil organic matter content is decreasing. There's too much bare soil during the winter, and there's a lot of soil at risk for erosion. Erosion may sound mild enough, as it's just the movement of soil across our landscape, but it has serious repercussions and safety concerns. It's one of the biggest concerns facing our farmers today, especially during the springtime when we experience those floods. With that being said, erosion isn't the only factor deteriorating our soils. Agriculture is necessary for us to eat, and over the years, we have converted 35% of the Earth's ice-free land from natural landscape to agriculture. This has resulted in erosion that causes a loss in organic carbon and other vital nutrients, acidification, salinization, waterlogging, and a reduced soil biodiversity. Acidification is our soils becoming more acidic. It's a natural process, but it's being accelerated by human activity. We do see it in agriculture through the addition of fertilizer, but we can also see it in industrial activities like mining. Salinization is the accumulation of soluble salts in portions of the landscape. Certain crops like beans and beets can't even survive with a low increase in salinity. Therefore, salinization reduces the yield of crops, limits the diversity of crops that can be planted in an area, which also results in an overall reduction in economic potential for our farmers. Waterlogging is basically what it sounds like. The soil is so wet there isn't enough oxygen in the pore space, which means the roots can't obtain enough oxygen to survive. Reduced soil biodiversity is also what it sounds like, that there's been a reduction in different nutrient content and therefore different soils. Which leads us to also having to house our growing human population. Urbanization also has negative impacts on our soils. Construction and paving over soil causes sealing and compaction, and this results in nutrient depletion and restricting water access for our vegetation. Industrial practices can also lead to potential contamination of our soils through heavy metals or other chemical pollutants. The Food and Agriculture Organization of the United Nations predicts that 1/3 of the world's soils is moderately to highly degraded. And we know how important soils are to wildlife health and our health. Therefore, we have to help our soils, and there's a lot we can do. All of these threats can be reduced through the adoption of sustainable soil management strategies. We can reduce erosion rates by adopting minimal tillage practices if we farm and use cover crops like winter wheat or crop residues, like chopped up corn stalks, to avoid having bare soil surface that's susceptible to effects of wind and water. This practice also helps promote healthy soil bacteria populations and nutrient presence, helping the overall soil biodiversity and health. This is a great example of a bare field. So this is after the harvest, but the farmer has taken away all of the vegetation. He hasn't left any crop residue, and that creates a bare environment, which allows, if there's lots of rain, or let's say during the flood season when the ice is melting, that means there's a lot of water coming off this field, carrying the sediment or leftover pesticides and fertilizers, and it's going directly into the waterway that is at the bottom of the field. So this is an example of a field with crop residue. They are barren corn stalks, and they're going to be left on during the whole winter, and that will help keep the sediment and water from just rushing into every body of water, helps with erosion, helps with slowing down the speed of the water, and helps with runoff. When we consider urbanization, we can implement different practices that still provide safe and aesthetically pleasing neighborhoods. Where we start is with urban planning. We have to view the importance of our soils from the beginning of the process, and always being prepared is better. We can implement practices like permeable pavements or rainwater gardens to allow for water access and slowing of runoff and groundwater recharge. We can also contact local conservation authorities or your Ministry of Agriculture, Food and Rural Affairs to learn more about soil conservation for farming, or to bring soil conservation practices and actions to the attention of your local, provincial, and federal governments. As an individual, there's a lot you can do. Be aware of where your food comes from and what soil management practices were used when making it. Get involved and just start talking to other people about soil and soil practices, just to get more people aware of how important our soils are. Always remember to practice the 4 R's: rethink, reduce, reuse, and recycle. Remember, recycling should be the last option. The best way to practice your 4 R's and help our soil health is through composting. And I'm actually going to show you, with our next activity, how to make your own composter. A simple way to assist with waste reduction, soil health, and even benefit your own garden is to compost your organics. To make a composter, all you'll need is a rubber bin or just an old tote that's laying around, some shredded paper, leaves, pine needles, or other brown organics, and some soil and food waste to get it started. First, you'll drill some holes in the lid and then the bottom of the tote. This allows for aeration within the tote and then also excess water to filter out. Then put in your soil to get your composted started, which should equal about 1/2 of the tote space, and then add the brown organics, which should take up about 1/3 of the space of the tote. Then you can add your food waste, add a little bit of water, and mix it all up. Then you have yourself a composter. You'll want to remember to mix your composter at least once a month. There's no harm in doing it more often though. Make sure your composter gets some sun and is not in a space that will get drenched by rain. Also, a very important note, do not put any oils or meat or animal byproducts in your composters, as this will attract wildlife. However, eggshells are fine. Have fun and see you in nature.